So our first speaker today is Dr. Katy Wolf. She didn't want to give me a picture, so I found this image that I think works. She is a genius chemist who has worked for manufacturers throughout Southern California and now through the West Coast to implement projects to help companies find and demonstrate safer alternatives and emerging technologies. Katy has conducted technical feasibility and cost analysis of more than 200 source reduction options in 13 different industries. Her evaluations include chemical substitution, process modification, product substitutes, and control technologies. Today, Dr. Wolf will review safer alternatives to vapor degreasing. So take it away, Katy. And in addition to sharing your screen, don't forget to unmute, Katy.
Can everybody see that?
Oh,
Not yet.
Really?
Do you all see it?
we wasn't live,
Say again?
so we can't see it.
I'm not sure what to do. Okay, let me see here. Share screen.
Oh, there we go.
Sorry, let me just get in full mode here. I'm sorry.
You're perfect.
Thank you for the nice introduction, Jean. That was very nice. And please be patient with me. I'm not that great at technology. I can only find safer alternatives to vapor degreasing, apparently. And that's, as Jean said, what I'm going to talk about today. Vapor degreasing is a process that's used by numerous companies across the country for cleaning their parts. And the dominant industries that rely on vapor degreasing include companies that manufacture and process metal parts of all kinds, as well as many different aerospace companies. And in 2016, Congress amended the Toxic Substances Control Act. Under the amendments, EPA was charged with developing regulations on chemicals that they believe posed a high risk. And they did develop a list of the first 10 priority chemicals. And on that list are 4 halogenated solvents that are used extensively in vapor degreasing. And those solvents include trichloroethylene or TCE, perchloroethylene or PERC, methylene chloride, and N-propyl bromide, NPB. And all 4 of these solvents are carcinogens, and they also pose a lot of other health and environmental effects as well. And in addition, all 4 of them are on the list of toxics in the Oregon DEQ regulation. Now, how does vapor degreasing work? Well, a vapor degreaser, as I show here in this simple schematic, it's a stainless steel tank, and it has a heater in the bottom and a set of cooling coils around the top. You put liquid solvent into the vapor degreaser and you heat it to its boiling point. That creates a vapor zone above the liquid zone, and those vapors of solvent would tend to escape from the vapor degreaser were it not for the set of cooling coils around the top. Now, when you want to clean parts, you load them either into a basket, or often people put them on fixtures of various kinds. And you put the parts into the vapor zone. And once they hit the vapor zone, the warm solvent vapors that are there, they'll condense on the colder parts and they carry the contaminants into the liquid below. So if you clean always in the vapor zone, you'll always be cleaning with clean solvent. Many degreasers are much more complex than the simple schematic that I showed. And almost all of them have a spray wand that you can use to spray liquid solvent onto the parts when they're in the vapor zone. Some degreasers also have baths of solvent with different types of agitation in them for better cleaning. You can immerse the parts in them. Now, this last point is very important, and I want to emphasize it. The solvents that can be used in open-top vapor degreasers can't have a flash point. If you heat a solvent with a flash point to its boiling point, you'll encounter the flash point first. And in open-top vapor degreasers, it's open to the air, so you have oxygen present. If you also have a source of ignition, you could ignite the solvent or you could blow it up, and that's very dangerous. So again, no solvents with flash points in open-top vapor degreasers. Now I'm going to talk about some case studies today, and I've just outlined what they are here. I'm going to talk about 4 companies I'm working with on an EPA Region 10 sponsored project with PPRC, and all 4 of those companies are using N-propyl bromide. I'm also going to give information on 2 case studies of companies that are in California. And that project is sponsored by the Hazard Evaluation System and Information Service, which is part of the California Department of Public Health. They are also using N-propyl bromide. Then I ran a nonprofit organization in the Los Angeles area for some 30 years. And I worked with many different companies, assisting them in converting away from vapor degreasing. And I'm going to talk about 2 of the companies that I worked with there. Now, before I talk about the potential alternatives that can be used in vapor degreasing, I'm just going to give you a little historical context of things. And after World War II, the solvent that started being used quite widely was trichloroethylene. And somewhat later, companies started using PERC and methylene chloride. By the time we hit the mid-1990s or so, a couple ozone depleting solvents were also used very extensively. They included 1,1,1-trichloroethane or TCA and a chlorofluorocarbon called CFC-113. Then in 1996, the United States joined the Montreal Protocol, which ended up banning the production of ozone depleting substances worldwide. And there were numerous companies using TCA and CFC-113 in vapor degreasing. So those thousands of companies actually had to convert to alternatives. So the vendors, of course, as always, they saw a potential new market. So they started introducing new solvents to the market. One solvent that was introduced at that time, one type, was called the hydrochlorofluorocarbons, or HCFCs. Now, they also contributed to ozone depletion, but less so than the CFCs. So they were phased out over the next 15 years or so. And then at that same time, N-propyl bromide was introduced onto the market. Then somewhat later, certain global warming solvents, the hydrofluoroethers and hydrofluorocarbons, were introduced. And finally, the last solvent that came on the market that I'm going to talk about was another chlorinated solvent called 1,2-trans-dichloroethylene. And over the years in vapor degreasing, there's been a lot of switching from one solvent to another, people switching from solvent A to solvent B as the one they're using is being increasingly regulated. Now I'm going to just go over what some of the potential alternatives are to the halogenated solvents. And the first set of solvents that I'll talk about as potential alternatives are the fluorinated solvents. Now, I already mentioned these. These are hydrofluoroethers or HFEs, and hydrofluorocarbons or HFCs. And these solvents do contribute to global warming. In addition, they don't clean very effectively. So virtually always when they're used, they're combined with 1,2-trans-dichloroethylene. Now, 1,2-trans has not been tested for chronic toxicity, but it is structurally similar to PERC, TCE, and vinyl chloride, and all 3 of those chemicals are carcinogens. So 1,2-trans may well be a carcinogen as well. The HFCs and HFEs are very expensive, And if you use them in open top vapor degreasers, the losses would be extremely high and you'd have to pay a lot of money to keep using them. So nearly always they're used in airless airtight equipment. That's things like vacuum degreasers that are very tight. And vacuum degreasers are very expensive. The smallest system you could potentially buy would run you about $100,000. But in most cases, they cost between $400,000 and $1 million. So the equipment's very expensive. Another fluorinated solvent is a hydrofluoro-olefin. There's a particular solvent that's used in these applications. It doesn't contribute to global warming, but a toxicologist in California has evaluated its toxicity and she believes it's cardiotoxic. So there could be an issue there. It is used in open top equipment, which is very expensive, and it's expensive itself. Now, a second potential option that you could use is to use solvents with flash points in vapor degreasing. This would include solvents I've already mentioned, which is 1,2-trans-dichloroethylene, and a number of other solvents that would be oxygenated solvents, things like glycol ethers or modified alcohols, MEK, things like that, or hydrocarbon solvents, things like mineral spirits or petroleum solvents. Now, as I already mentioned, you can't use solvents with flash points in open top vapor degreasers, so you need to buy the airless airtight systems. And once again, that would run you $400,000 to $1 million. In addition, some of the solvents, like certain glycol ethers, for example, and some most hydrocarbon solvents actually, which contain aromatic components, they could be toxic. Now, a third potential option is to use solvents with flash points in cold cleaning. That would be where they weren't heated at all. And I've added a couple solvents to the list, one called perachlorobenzotrifluoride, or PCBTF, another group of solvents called volatile methylsiloxanes. And some of these are toxic. Recently, they've found PCBTF to be a carcinogen, and the volatile methylsiloxane that's used in solvent applications, it's called D5, and it's also a carcinogen. In addition, cold cleaning really isn't as effective as a process as is vapor degreasing. So most people using vapor degreasing wouldn't find this adequate. Now, I've separated out soy base cleaners, which I list here, and they're appropriate for cleaning certain types of contaminants. For example, companies that make optical components, they polish their components with pitch and wax, and those are difficult to remove. And it turns out that soy base cleaners are particularly effective in removing those contaminants. There are various other methods that potentially can be used by certain companies on a case-by-case basis. For example, certain companies might use a burn-off oven to decompose some of the lubricants they have on their parts. Companies assembling printed circuit boards may be able to convert to a no-clean flux, which they then wouldn't have to subsequently clean off at all. And other companies bringing in heavily contaminated parts from the field for refurbishing might be able to use blasting media to do their cleaning. Then the last option that I list is water-based cleaners, and I'm going to talk a lot more about those in a few minutes. Now, taking into account the things that I've said about health and environmental effects, the cost, the technical feasibility issues, it does turn out that water-based cleaners are the best option, and they are appropriate for virtually all of the operations that today use vapor degreasing. Some other operations can convert to soy-based cleaners, which I mentioned, or the other non-chemical methods that I talked about. In the PPRC project, we've tested water-based cleaners for all the facilities, and they are suitable. In my California project, one of the facilities actually makes optical components, so they're converting to a soy-based cleaner, and the other has converted to a water-based cleaner. And in my earlier projects in the Los Angeles area that I'll speak about, both facilities converted to water-based cleaners. Now, the first case study I'm going to discuss is a company called Mapsco in the Seattle area. And they are a subcontractor and they offer non-destructive testing services. The type of non-destructive testing that the company has is magnetic particle inspection. And the way that works is that you have a fluid and it's got magnetic particles in it. And you put the parts that you're going to do the NDT testing on into that fluid and you apply a magnetic field. If the parts have a flaw or a crack in them, the magnetic particles will line up along that flaw or crack. You'll know where it is and you can do the repair instead of discarding the parts. So it's really a good type of process. And historically, Mapsco used a really large 130-gallon N-propyl bromide vapor degreaser for their cleaning. The company also had some water-based cleaning operations in their facility, and they wanted to use the same water cleaner that they were using in those. So we did the testing with the water cleaner supplier, and we found it to be an appropriate cleaner. And I then contacted an equipment manufacturer who I brought in, an equipment supplier, and he had the type of equipment that they would need to clean their parts. It's an immersion agitation type of equipment. And he gave them a quote. They felt it was too high. He represented another company that had lower cost equipment, but Mapsco also thought that quote was too high. So Mapsco did find a secondhand system, but another company bought it up before they could. So I got in gear and I found a company that had secondhand equipment of all kinds, and they happened to have a system of the type that we had originally quoted. Mapsco did purchase it, they installed it, and they've been operating it for several months, and they find it very good. This picture shows it's the non-destructive testing cell that Mapsco has. And here's a picture of the 130-gallon N-propyl bromide vapor degreaser the company used to use. This slide shows the water cleaning system they purchased. It's made by Ramco. It has 3 chambers. And as I mentioned, it's immersion agitation. The first chamber is a wash bath, the second is a rinse bath, and the third is a forced air dry. As you see from the picture, it also has an automated handling system that indexes the baskets in and out of the proper cleaning cells. Now this slide shows a comparison of the annualized cost for Mapsco on the one hand for using the vapor degreaser and on the other hand for using the water cleaning system. Now, I like to present costs in terms of an annualized cost because I think it's sort of inherently understandable. And you'll notice that I don't have a capital cost for the equipment, the vapor degreaser in this case. And I generally don't include that cost. Most people's vapor degreasers are really old. They've been completely paid off and fully amortized. So I don't include that. In contrast, I do include the capital cost for the water cleaning system. Now, in this case, the cleaning system itself cost $55,000. The company also did an upgrade of their electrical system to accommodate the water cleaning system, and that cost $12,000. So the total capital cost, a one-time cost, was $67,000. Now I amortized that cost over a 10-year life for the equipment, even though most water cleaning equipment would probably last 20 years or even longer. But to be conservative, I used a 10-year life and I used a 3% discount rate. Now, as you see, the cost of using the N-propyl bromide solvent is higher than the cost of using the water-based cleaner. That's a consequence of the fact that water cleaners are generally sold in concentrate form, and they run about $20 a gallon. Now you're going to dilute that water cleaner to maybe 5 or 10% of its concentration in water when you use it. So it's really very low cost to use that water cleaner, particularly if, and you don't need to change it out very often if you have good oil control and filtration, which we do have here. And in this case, the company only needs to change that water cleaning bath out twice a year. So it's very conservative in that way. Now there's a $75 cost for the filters per year in the water system. Now, as you see, the energy cost for using the N-propyl bromide degreaser is a lot higher than the energy cost for using the water cleaner. You have to heat N-propyl bromide to its boiling point of 160 degrees. And their vapor degreaser had 2 sets of cooling coils around the top. So it took a lot of chiller capacity to keep that cool. So that's why that's higher. Now, as you see, we've increased the labor cost a little by moving to the water cleaning system. Mapsco added another cleaning process to the water cleaning system when they converted. And it's a process where parts are put through a masked operation. I don't show a cost for the personal protective equipment for the vapor degreaser. If you remember, it's an enclosed system. Now, as you see, the disposal cost for getting rid of the halogenated solvent is really quite high. That's so high because halogenated solvents actually have to be incinerated. Now, I don't show a cost at all for disposal of the water cleaner. And that follows from the fact that Mapsco has a wastewater treatment system that treats very large volumes of wastewater. The amount of spent water cleaner that they have to treat from the water cleaning system is very small compared with the amount of water they treat from other processes. So we decided to deem that negligible and didn't include it. Now, as you see, the total cost of using the vapor degreaser is higher than the total cost of using the water cleaning system. Mapsco was able to reduce their costs by some 27% by moving to the water-based cleaning system. Now, another company I'm working with in the PPRC project, they manufacture small diameter tubing, 1/8 inch or larger. And those tubes are used to transfer liquids and gases from one place to another in aircraft. And in order to do, if you can see these tubes, the pictures here, and some of them are 4 to 5 feet long and they have multiple bends in them. The company needs to do bending, and that's a very stressful operation. They're using a water-based lubricant. Now, we worked with a water cleaner supplier and conducted some testing. We identified a water cleaner that would work for their parts. Then I contacted an equipment supplier, and the equipment supplier and I knew of another company in California that had a very similar operation, and that company had converted a few years before to an ultrasonic system. We believed that the ultrasonic system was very expensive and that we could perhaps clean the parts in a less costly system so they wouldn't have to pay for so much for the alternative equipment. So we did testing in a spray cabinet with a specially designed fixture. That testing was successful. The parts were sent back to the company. They cut them apart and said they were clean. And the company now has quotes for both the spray cabinet with the fixture and an ultrasonic system. And as expected, the quote for the spray cabinet is lower than the quote for the immersion ultrasonic system. A third company I'm working with in the PPRC project manufactures ducts. They make ducting for industrial and aerospace applications. And in order to do the forming process, they use extreme pressure lubricants, and they're difficult to remove. And the company has several water cleaning systems throughout their facility, and they wanted to end up converting to a water cleaner, no more than 1 or 2 at the most throughout their facility. And we did testing with a couple different water cleaners and can remove the extreme pressure lubricants that right now go through the N-propyl bromide degreaser. And the company plans to convert to one of their existing water cleaning systems. It's an immersion agitation system. The fourth company I'm working with is a plater, and the company polishes their parts of various kinds, and polishing compounds are very difficult to remove. In this case, they have to use an ultrasonic cleaning system, which is very expensive for removing those contaminants. And we've tested water cleaners. We found one that was suitable, and the company is considering what size of an ultrasonic system they can purchase. Now, in the California project, I worked with a manufacturer of microelectronics for medical devices, and that company needed to have FDA approval in order to convert. I provided them with some information that they then used, and they were able to get that approval. Partway through working with them, they told me they had a water-based cleaning system on site already, and it was a very different kind of system. It was used with a water-based defluxing agent to remove flux from printed circuit boards. Now, that isn't the ideal cleaner I would select for the microelectronics components, but I felt like it might work, and that way it would be less costly because they wouldn't have to purchase an additional system. So we did the testing, and they did a lot of quality control to determine whether the parts were clean. They ended up being clean, so this company was able just to put the parts that they had previously put through their vapor degreaser through that water-based defluxing system, a small dishwasher actually. Now, the second company that I'm working with that I already mentioned is an optical components manufacturer in California. And we did testing with that company to remove the pitch and wax that they use for polishing their components. And we verified that a soy base cleaner can effectively clean their parts. I brought in 2 suppliers of equipment to give competitive quotes, and the company is evaluating them. Now, I'm just going to present a case study of a company in the Los Angeles area that I worked with, and they manufactured valves of various kinds. They brought them in from the field to refurbish them. They were made of all kinds of substrates, as you see that I've listed here. And the valve bodies had a lot of lubricants, different types of lubricants on them, and also some strange things like bakery flour residue. And historically, the company cleaned the parts in a 35-gallon open-top vapor degreaser. And they cleaned the parts when they came into the facility before they brazed or coated them. We did testing and found a water cleaner that was suitable, and the company ended up converting to a water-based cleaner in a spray cabinet. And here's a picture of a typical spray cabinet, and it has a turntable on the bottom where you place the parts, and it has a spray bar which is adjustable, and it sprays water-based cleaner onto the parts. Spray cabinets like this can have a wash, rinse, and a dry, but in this case, we're only doing a wash. It's a gross cleaning operation, and so that's all we need. Now, here's the annualized cost comparison for the valve company. And once again, I don't put in an equipment cost for the vapor degreaser. I do put in a cost for the water cleaning system. In this case, the spray cabinet was $8,000. So again, I've amortized that over a 10-year life for the equipment with a 3% discount rate. As before, in the other case study, the cost of using the solvent is higher than the cost of using the water-based cleaner. Now, in this case, because it's a gross cleaning operation, we need to change out the bath more frequently, and we change it out every month and a half. But even so, that cost is less. Now, in this case, as is true in many cases, the energy requirement for the water cleaning system is higher than the energy requirement for the vapor degreaser. The labor cost has remained about the same. And as before, the cost of disposing of the solvent is higher than the cost of disposing of the spent water-based cleaners. Now, the water-based cleaner, in this case, they dispose of it off-site. And so that's what they have to pay, $800 a year for disposing of that water cleaner. As was the case earlier, again, the cost of using the vapor degreaser is higher than the cost of using the water cleaning system. And the valve company was able to reduce their cost by some 18% by moving to the water cleaning system. The last case study I'll talk about is a nameplate manufacturer. The company manufactures nameplates made of different substrates, and 90% of them are aluminum, and the balance is stainless steel and brass. The nameplate stock comes into the facility with a protective oil coating, and they need to clean them prior to processing them. And historically, the company was cleaning in an open top 50-gallon vapor degreaser. And they were cleaning a huge number of nameplates per day. 1,000 nameplates per day went through that degreaser. We did testing, found a water-based cleaner that was suitable, and they ended up buying a conveyorized spray cleaning system. Here's a picture of the conveyorized system they bought. And as you see, it has a conveyor belt at the entrance, and you place the nameplates on there, and they move through the unit. And there's a wash section where you spray high pressure water-based cleaner, maybe at about 120 PSI onto the parts. They then go through a recirculating rinse in this case. And that also sprays, and it sprays deionized water onto the parts. Then the third chamber is a forced air dry, and the parts come out, the nameplates come out the other end on the conveyor belt, clean and dry. Now here's the annualized cost comparison for the nameplate manufacturer. Again, no cost for the capital cost for the vapor degreaser. The water cleaning system in this case cost $150,000. It was very expensive, and that included the recirculating rinse feature. And when I amortize that over a 10-year life using a 3% discount rate, I get about $17,000 a year. Now, as before, the cost of using the solvent is higher than the cost of using the water cleaner. In this case, we have to change out the bath roughly every month and a half as well, because they run a huge volume of parts through that cleaning system. Now, in this case, the cost of using the water cleaning system has a much higher energy cost than for using the vapor degreaser. And that follows from the fact that the system is quite automated, as you saw. It's a conveyorized system. And when you use automation, you increase your energy costs. Now, in contrast, we lowered the labor cost. Again, the automation helps you to do that. So that labor cost is lower with adoption of the water-based cleaner. The disposal cost, again, is higher for the getting rid of the solvent than it is for disposing of the water-based cleaner. They do dispose of the spent water cleaner off-site in this case as well. Then I show a row for deionized water here. And in the Los Angeles area, the quality of the water is very, very poor. And if you want spot-free parts at the end of your operation, you absolutely have to rinse with deionized water. And that's in contrast, by the way, to the Pacific Northwest, where the water quality is really good and people can use tap water here. So the deionized water cost is about $3,000 per year. They have to change the canisters out frequently. Now, again, the total cost of using the vapor degreaser is higher than the total cost of using the water-based cleaning system. The nameplate company was able to reduce their cost by about 22% by moving to the water cleaner. Now, you're going to ask, of course, is it always less costly to convert to the water-based cleaning system? And the answer is no, not always. It mostly is, but not always. I mentioned the tube manufacturer that I'm working with earlier. And when that tube manufacturer converts, the company is going to pay more for their water cleaning system. It will be more costly. Now, I just want to mention some issues that I encounter when I work with companies. Companies start out wanting a drop-in alternative. They have an open-top vapor degreaser and they want to keep using it. And often they're very, very old. And I hope I've convinced you by going over the advantages and the disadvantages of the potential alternatives to show you that there's nothing you can really drop into that open-top vapor degreaser. And vendors, of course, particularly the suppliers of the solvents that you're using right now, they'll carry other solvents and they may try to convince companies that they can use something when they really shouldn't. Vendors are marketing 1,2-trans dichloroethylene for use in open-top vapor degreasers, and that solvent, as I mentioned, has a flash point. So that can be very dangerous. So companies need to not do that. Then I also find that companies don't believe that water-based cleaners will either work effectively or they think they'll rust their parts. So I work with water cleaner suppliers, and you can send your parts that are typically contaminated to a water cleaner supplier. They'll test in their lab in the appropriate type of equipment, and they'll find a water-based cleaner that works for you. They'll send your parts back and you can evaluate them. And all of that they'll do for free because they want your business. So I find that when we do that with parts, companies become convinced that water cleaners will work. Then a third issue is that I always try to make the systems as low cost as possible. I talked about the secondhand system that I found for MAPSCO, and also about testing in the spray cabinet for the tube manufacturer versus the ultrasonic system. And finally, COVID-19, of course, has affected business activity for many companies, but not all. And one of the companies I'm working with, the optical components manufacturer, their business declined quite a bit. And we're waiting for them to purchase the alternative soy-based system until their business comes back up to speed. Now, just to conclude then, water-based cleaning systems are really the most appropriate alternative, and they're suitable for nearly cleaning the parts in nearly all vapor degreasing operations that are used today. And in certain cases, non-chemical alternatives or soy-based cleaners can be used as well. And I hope I've convinced you in going through this that there really is no drop-in or magic answer, and that you have to actually do the testing and the work to get into an alternative. And that leads you to the best strategy, which is to find a permanent solution so you don't have to convert it again. Here's my contact information again. Please, I am listing my phone number and my email address. Please feel free to contact me if you use solvents and want to have a discussion about how you might convert to alternatives. And I will be glad to answer questions in the question period. So that concludes my presentation.